Yeah.
Yeah, I can.
Okay. Sorry. That's always good to check first. All righty. Well, I want to start by telling you a little bit of a story. Let's meet Rick here. Rick is a systems architect, and he works on the core services team. And his colleague here, Morty, who is an app developer, he works on the billing team. And Rick and Morty, they work for a large scale company that develops and produces a SaaS application. And about a year or so ago, they decided to move to the cloud. So they're still relatively early in their journey. And after kind of an impactful all hands, they start to kind of talk offline afterwards and reflecting. And Rick, kind of says, hey, I'm working on this Terraform code, and it deploys a data tier, and it adheres to all of our security requirements, our retention policies. It even adds logging. And this really excites Morty because he says, hey, I've been doing the same thing for our team. And as a matter of fact, I just added this cross-region backup strategy that's really going to be apparent as we start to go across multiple regions. And of course, Rick says, oh, that sounds great. Why don't you go ahead and send me that code so that I can incorporate it into my own code. This is, a pretty common situation, especially as, customers are getting started into Terraform. So we're going to talk a little bit about how do Rick and Morty solve this problem, not just for their use case, but really for the organization as a whole, so that they can scale appropriately. My name is Tom Straub. I work for HashiCorp in our implementation services team. And what we do is we deploy, adopt, and scale our enterprise solutions for our clients. And, my Terraform journey, started, just over 5 years ago, in the 0.6 days. It's been really exciting to see the product unfold and mature. And I think we're all looking forward to, eventually getting to that 1.0 milestone. But it's been a really great thing to see. And what I love about my job and my passion for Terraform is they get to kind of work together. And I get to see a lot of different creative solutions with our technology. So I get really excited about that. And, in that process, I was given this nickname, Terraform Tom, that, I wear as a badge of honor. I'm humbled by it. I try to live up to it. And as they say, the rest is history. So I'm going to stick around after the talk in chat if you have any questions. Hopefully we have some time for some questions as well, but just keep in mind, if you'd like to ask something, I'm happy to help. All right. So Rick and Morty, they're, thinking about how do they share their code. It might be apparent that, we're going to leverage a Terraform construct known as modules. And really, to get started, what is a module? And it's really just a set of Terraform code that is like a container that holds on to those files. Oftentimes, this code lives in its own repository. And in fact, it could actually be maintained by multiple teams or different teams. But that's how we would go and share it. Now, if I have my Terraform code and I want to reference one of these modules, I can just use a declaration here. And I leverage this meta argument source. And these sources can actually take on a lot of different and interesting forms. Some of the more common ones are really a Git repository link or what we call the Terraform registry. One important kind of technical bit here is this value is what we call a string literal. And what that means is it cannot be interpolated. So we can't use variables to kind of inject values into that. It's by design, and we have to account for that as we're designing our modules. And at the end of the day, it's really just a set of inputs and a set of outputs. That's really what you're exposing. Now, that Terraform registry is really a very nice thing. And if you're out in the open source world, anyone can use what we call the public module registry. You can publish to that. You can pull from that. You can interact with it for free. Now, some of our clients, they don't necessarily want that. So we do have what is known as the private module registry. And those are exposed and unlocked with our Terraform Cloud and Enterprise offerings. The real benefit, or at least one of the real benefits of a registry, is the ability to leverage this version meta argument. We'll talk a little bit more about this, but this unlocks a lot of interesting scenarios. Now, because we've taken our Terraform code and we have pulled it out into its own repository, we're introducing a new dynamic. And I like to call this the Terraform producer and the Terraform consumer. Now, they have different concerns. A producer is really interested in making the right thing. They also likely are a subject matter expert within their organization around Terraform and maybe even their cloud environments. And in a way, they also are responsible for the user experience of their module because they get to control the inputs and the outputs. Now, on the other side, a consumer, they're concerned with getting the right thing. They certainly understand Terraform. They have some knowledge, but they don't necessarily have the same level. They don't need to have the same level. And at the end of the day, that module to them is more or less a black box when they actually go to run Terraform apply. So understanding and embracing this dynamic, when done right, is how organizations can really scale because they don't need full-blown Terraform experts to be able to use Terraform in their organization. So Rick and Morty, they're all in on modules. Yes, let's go and write one. The first thing that they're probably going to ask is, what and how many resources is going to go into my module, right? And I'm going to demonstrate two extremes here so that we can kind of figure out what makes sense. In one scenario, we could create a module for every resource that we're going to deliver or deploy. Oftentimes, these variables are very one-to-one with the arguments exposed by that resource, and the outputs are simply just passing in the values that are created by that resource. This tends to create a very high touch and limited return on investment for a module that should be avoided and can cause a lot more pain and complexity than it's worth. Now, on the other side, we might have a module that has, all the resources, right? Call it mega module, right? And, this introduces another set of problems, and that is because we have so many resources, oftentimes we've nested logic in here. There's additional complexity. It becomes very difficult to test and debug these modules. And because we've touched so many different, aspects of our app or our infrastructure, the reason for the module to change is also high. And these can all be roadblocks to scale. Now, what's the answer? Well, it's somewhere in the middle, right? And it's really up to you and your organization to determine what's the level of abstraction that makes sense for your modules and how they're going to be consumed. So there's no perfect answer here. And resource count, not necessarily a great indicator of health, but it will give you some ideas on if you're fading one side of this spectrum or the other, you might want to take another look. So what are some things that we should look at when deciding what resources to go in there? Well, if I have a module that's already deployed and I were to run a Terraform destroy, what is going to happen? What systems am I going to affect? How many unrelated resources are going to be destroyed? Also, if I were to make a change, how do those resources within that module change? What's the frequency of their change? And also, how do they change relative to each other? Maybe a good example here might be if I have a module that deploys security group roles that are very static. Maybe I'm just opening up port 443, and that's really it. It doesn't change very often. But then I'm doing a lot of stuff with my application, like servers and databases, and those change quite frequently. I may not want to put these in the same module, just something to consider. And then really the other consideration here is what dependencies are needed. Most modules need something, right? They need something to live in the environment or input into it to execute. What are they, right? And then also your module might be a dependency for something downstream. So what is that rate of change? These are all the things that you would want to think about when deciding what resources to put in and not put into your module. So Rick and Morty, they have a little sidebar. They're relatively aligned on the number of resources and what it's going to look like. it's time for them to structure their repository. Now, this may seem like a simple entry point, but it's often overlooked. As I'm developing Terraform, simple things like my variables, do they go into variables.tf file? My outputs, do they go into outputs.tf file? It doesn't really matter what you call these things. And in fact, Terraform doesn't really care if this is one file or 100 files. But what is important is to define consistency within the organization, because as you're scaling out, you're going to have more people looking at your code and hopefully contributing. And the easier it is for them to look at that code and understand it without having to dig is going to help you scale. The last thing that I want to say about variables and outputs is there is an argument called description, and it's not there by accident. You should fill out those descriptions to be to let the consumer know what those variables are, maybe even what the values should and shouldn't be. And really, it just ties back to that producer consumer model. As the producer, what can I do to ensure that my consumer is able to understand what my intent was behind certain variables? Most and pretty much every modern version control system, if you navigate to it in a web browser, what do you see? And it's a rendering of the README. Now, this is not by accident. The reason why is because this works. So include a README. Why does your module exist? What came about? What were the decisions that went into how you built it? You might also have known issues with the module or future roadmap items. You could also even link internally to like a ticketing system or whatnot. The other thing that I really like to see in here, and we see this so much in the open source community, but not so much when we actually write our own code internally, and that is, how can I contribute? How can I raise issues? How can I help this module get better? So you almost can crowdsource internally like you would in the open source world, just obviously not totally open. The other thing here is change is inevitable. It's going to happen. You are not going to write your module perfect the first time and satisfy everything. So a change log is another great addition. What caused the change? Did you add a resource? Did you remove a resource? Anything like that will be very valuable to the folks that are consuming your module. Having an examples directory is another great way, especially as modules become more complex. You know, do I have several use cases that I'm targeting? And again, what's the intent behind that module's use? So you could be satisfying several different scenarios. Maybe having a quick example, will help your end user understand how to leverage your module the best. Testing is a deep topic, and it's kind of, on its own, it could be a talk. What I will say here is, put thought into how you're going to validate and verify that your modules are operating, correctly, and standardize that as a company. This may not be something that you start out with, but it is something you aspire to. But make sure that you're thinking about this and you're working towards progressing module releases. Now, the overall point here behind the structure of this repository is it's overhead, it's work. It's not free. So when you think about adding additional modules, keep this in mind, that what value are you getting, and are you jumping in at the right time? All right. So Rick and Morty, they're ready to write code. They're tired of talking about module structures, right? One of the things that I mentioned, and this is very common, modules typically require some type of dependency. In this case or example, it's a VPC, but I don't want you to get stuck on it's an AWS VPC. It's just it's just a dependency that I need. And a typical first approach might be to do something like this. I expose a variable, I do a data lookup on the name that is passed in, and then I can reference it, in this case, in a security group. Now, this may look good, and in fact, it's valid Terraform, it will work, but it does introduce a few challenges as we look to scale. So one of them is, we, as the producer, remember, when we wrote this module, we decided how that consumer will look up their VPC. So we've said, hey, you have to pass in a name and it has to be tagged with a name, and that's how we're going to look it up. So there's many ways to query and data look up a VPC or other resources. You're restricting how consumers can do that. Another challenge we have here is if that VPC is being created or that dependency is being created out of band of your Terraform, if you've already applied your module, you can run into challenges trying to run a plan or even to destroy because that data lookup is going to fail. And remember, it's inside your module. The other piece here, specific to data lookups, when we think about Terraform 0.13, we added, Terraform added a new feature where we can run for each on a module. So imagine I'm calling a module maybe, 100 times, and I'm looking up the same resource every single time. Additional API calls that, on a small scale may not actually cause you much pain, but, at a large scale could. So something to think about. Now, if you're familiar with developer principles, you might look at this and it might scream to you that this is actually violating what we call the dependency injection principle. And really, what can we do to maybe make a slight refactor, but really open the door for scale? So if I took that module and I said, I'm going to rewrite it just a little bit, I'm going to make a small tweak. What I've done here is I've removed the data lookup, and instead in my module, I'm just exposing a variable for the VPC ID. Now, this seems subtle. And of course, I still have to look it up or potentially. So what would that look like? So my consumer in this case is just, grabbing my module example, nothing fancy here. And their lookup is at the next level up. So we really just moved it. So, okay, that's great. Well, what if another user or another team is actually generating their VPC as part of their Terraform run? Now they can generate it like they normally would, and they just simply pass in the VPC ID. Or let's say there's an external system that's managing those dependencies and they're injected in some build server. I can just expose it all the way up. So this subtle change, what value did it add? Well, I was able to use this module in 3 different scenarios without changing the module. It didn't require a change. And that is where there's a lot of value in what in adhering to this dependency injection principle. So Rick and Morty are looking and they create their repository, and they say, hey, did you know, fun fact, modules can call other modules. And they start to break everything down. And they end up with something like this. And each one of these boxes is its own repository, right? And it has its own change cadence, and they wire everything up. Well, beyond just being potentially overly complex, if a consumer runs into a problem, how difficult is it going to be for them to find the answer or find what is actually causing the problem? And also, they may not even know which team to go to actually get it fixed. So this can cause some problems. The other thing here is if we think about the very bottom of this tree or this dependency graph, if there's a change, it can have this ripple effect through your declarations. And one simple module change could actually require changes in 3, 4, 5, or maybe 10 repos. I mean, depending on how deep this chart goes. So it's something to keep in mind. Now, let's take a look at a code example to maybe bring this in a little bit. So here, I want to create a module to deploy a console cluster. That's a pretty common ask. So this is how someone's going to reference it. But if they were to go into my source code, what they would see is I've got multiple module calls. So for VPC and servers, and then if they were to go in the VPC, they'd find there's another module call, and it might keep going and going and going, right? Keep in mind that each one of these modules has its own set of variables and its own set of outputs. So what we end up with is just an absurd amount of overhead for something that we might not actually get any value from, okay? So how would we maybe tweak this? How do we change this? Well, if we needed to reference other modules, we would keep it flat. We would try to have a very shallow depth tree to make it a little bit easier to understand. And I'm going to show you some code here because I think it drives home that this is leaning into that dependency injection concept. It's creating a simpler interface. And what I like about this is it almost kind of reads like a book. I mean, order doesn't necessarily matter within Terraform in the file, but I'm creating the VPC first in this case, and then security group servers. These are just examples, but whatever you're calling, that is what's going to you're going to be able to kind of follow it. Now, Rick and Morty, they've done their development, they're feeling really good, and they're ready to release. Okay. Well, within Terraform, we really recommend, and the registry actually forces this as well, is to leverage semantic versioning. Now, semantic versioning is not unique to Terraform, right? It's very ubiquitous in the field, but it's because it's simple and it actually works, right? And at the end of the day, we really have these three different numbers, right? And, a patch number, we might increment that when there's a bug fix or a typo, right? And a minor version might be, we added a new resource or maybe changed something a little bit more impactful. And then a major version might be totally new behavior, right? Now, if we go back to Morty's, change where he's saying, hey, I'm adding cross region, that might be something that you decide is a minor version update because you can do it maybe in place. Or you might say, no, that's too big of a lift. I want to create a new major version and create and force folks to net new. The important piece here is that you discuss and formalize this internally. So you take the gray out of that decision, right? And it's one thing to say, hey, we use semantic versioning, right? It's 100, that's it. But it's another thing to actually walk it. And what do I mean by that? If we decide that I've deployed 100 and I should be able to take the next patch and apply on top of that successfully, I should be able to do that. Same with minor, and then maybe major, you're saying no. Again, it's really up to you to decide which of these boxes are green and which are red. But at the end of the day, are we testing this? And what do I mean by that? Am I actually deploying version 100 somewhere and then trying to apply on top of that 101 and validating that to build at least some level of confidence that it's going to work? So, if you can buy into that and you actually are testing that, it can unlock some interesting scenarios. If we think back to that registry and that version, the important thing here is we can leverage version constraints. And this is just like with, provider versions and Terraform core versions. And, in this example here on the left, these are all the versions of the module that are deployed to the registry. So they're reachable, they're findable, everybody can find them. And of course, I can just say equals 100. I will always get version 100, forever and always, right? If I want to make a change, I have to update the code. Well, my favorite version constraint is pessimistic version constraints, which is a tilde greater than. And what that will do is the rightmost digit that you actually have in your string, it will allow that to float forward to the highest number available. So in this case, if I have tilde greater than 1.1.0, because 1.1.2 is available, it's going to grab that. And it's going to skip over version 2.0. It doesn't really care about that one because of how we've constrained it. So this is something that can really, you tread a little lightly here because you want to make sure that you are actually testing these things before you're pushing changes like this out into production. Keep in mind, though, the great thing about Terraform is you get a nice plan. So hopefully you're catching and checking things before things are going out to prod. All right, well, let's check back in on Rick and Morty. They have done a lot of stuff. They set out on this journey to jump in and write a Terraform module, right? They're ready to actually have users start using it. And it breaks everything. You will ship a bad version. It's going to happen. So what's the advice? Create a process to deprecate versions. Don't let them stay out there. Don't set your consumers up to fail in a version that 20 minutes after you released is actually no good. Those should also include feedback loops into your testing process and things like that. Now, I want to leave just a couple other things around that Rick and Morty would do maybe day 2, right? In terms of scale, module discoverability. That situation at the beginning, it would have happened anyway if they were both using modules, right? If they didn't know that each other were building those modules. So make it so that folks can find those things. The Terraform registry is a good place to do that. Also, that release pipeline. If you're going to release your module, test it, deploy it somewhere. It can be as simple as Terraform apply, Terraform destroy in a sandbox, and it's good. That will build some confidence, right? And you can grow from there. And then the last one, go when you're ready. Do not jump in and create 100 modules because you think it looks cool and the module declarations kind of line up and things feel. Keep it simple. Don't overcomplicate it, and trial run a few modules and then grow from there. So you're not, overburdened with a ton of, a ton of existing code. All right. I want to thank you. It's been a pleasure talking with everybody. If you are thinking about becoming a customer of HashiCorp, consider reaching out to your sales team. My team and I can help, and we'd be happy to do that and get you started down your journey.
Awesome. Thank you
so
very
I think
much,
we do
Tom.
have a few minutes. So I'm happy to take some questions if there are.
Yes, I was going to say that there is a question in the YouTube channel, YouTube chat. I'll read it for you. I lost. Oh yeah. How often do you folks split up Terraform behemoths into groups of modules rather than going the mono repo route?
So how often do you put more modules in one repo?
I guess it's, well, I mean, I think some other people answered like their version or gave their version of the answer, but I guess my interpretation is, how often do you, like, if you have 1,000 lines of Terraform, how often do you split up into actual different like Git repos as opposed to like one big thing? Or as opposed
I think it's
to
around
multiple modules within the same repo. Does that make sense?
Yeah. So if there is a concept of a nested module. A nested module would be local, but not exposed externally. That's really up to you. I think mixing modules in the same repository can have some negative effects because the change cadence. I have to version them together. And it can be difficult to do. So your mileage may vary. Take a hard look at that, make sure that it makes sense for you.